In this circuit diagram, we're asked to use the mesh current method to find the power dissipated in the 2 ohm resistor in the circuit shown below. For power, we know we have a couple of different formulas. 2, I'm going to write out, is that power is equal to voltage times our current. We also know that our power is equal to our current squared times resistance. We're going to be using this formula because we are given resistance right here. We know this to be 2 ohms. So we can just plug 2 ohms into here. Now we need to find the actual current flowing through this. And to do this, we're going to use the mesh current method. The mesh current method makes us look at all of the currents flowing through these individual parts. So there's going to be current flowing through like this, and we're saying that it's going this way. So we can draw arrows indicating direction like this. And we are going to have the same thing, but on this part right here. And we're also going to have the same thing in this part right here. So we have 3 different currents flowing through here. We'll call this I1, I2, and I3. Now all we need to do is analyze the actual currents both flowing through here. First thing that's flowing through this I1, we're going to look at this I1 first, is our 30 volts right here. And our 30 volts goes from our positive into the negative, like this. This is the way a voltage drop. So we are going to have a negative 30 volts, since this is going in the opposite direction of our current that's flowing through the system. Now we can add up all of our resistors, because if we're just looking at this resistor, and this resistor in terms of the I1 current, they're all in series. And series resistors can add together because the current flowing through them is the same throughout. So we're going to do a plus 11, again, because we added them all together, I1, and this is in ohms. Next, we notice that our 2 ohm resistor shares the side with this I1 and this I2 current. So we have to kind of do something about that. When we look at both of these currents, we know that our I2 is going up this way into the 2 ohm resistor. We know that our I1 is going down this way, and that's why it's positive. Since our I2 current flowing through here is going in the opposite direction, we are going to have a minus, and this is going to be the total of the resistor, which is 2 I2, because that's the current type, ohms, that's the unit, and this is all equal to 0. This is kind of a variation of Kirchhoff's voltage law. That's why we are looking at all of the currents or voltages around our closed system. Now we are going to analyze I2. In I2, we have this 2 ohm resistor, this 8 ohm resistor, this 5 ohm resistor, and this 4 ohm resistor. Since the current is flowing through all of these in the same direction, all we need to do is add them together. So we have a 19 I2, and this is in terms of ohms. Now, we're going to do the same thing. If our I2 is going up this way, and our I1 is going down this way, they're in opposite. That means our I1 now is going to be in the opposite direction. And since our actual direction for I2 is positive, that means I1 is negative. So we're going to have a minus 2 I1, and this is in terms of ohms. Same thing for our I3. For our 5 ohm resistor, we know that our I3 is going up this way, and we know that our I2 is going down this way. Since they're in opposite directions, I2 is positive, that means our I3 has to be negative. So we're going to have a minus 5 I3 in terms of ohms, and this is set equal to 0. So far we have 3 unknowns, I1, I2, and now we have I3. Well, the I3 current is actually given to us right now for this exact problem. It's given to us as 16 amps. This won't always be the case, but for now we can just use this 16 amps because since our 5 ohms is in series with it, it's the only current flowing through here in our closed system. It's important to note though that our current is flowing up this way and our I3 is flowing down this way. So they're coming together, and since they're going in opposite directions, that means this I3 right here has to be a negative 16 amps. Again, since they are in opposite directions. Now we're just going to combine like terms and move some stuff around. So for the first one, I'm going to move the 30 volts to the other side and then divide everything by ohms. That way we're going to get 11 I1 minus 2 I2 is equal to 30 amps. And this makes sense because I is in resistance. We're going to do something similar for our bottom one. I'm going to have a negative 2I1, so this is in front. And then again, I'm dividing everything by ohms. And we're going to get a plus 19I2, and this will be set equal to a negative 80 amps. The reason why it's negative, because when we combine these two negatives, it's going to be positive, and then we subtract it from both sides to get it to be negative. Now we have two unknowns, and we can go about doing this two ways. I'm going to do the way that I think is the easiest and just find our I2 here and then substitute into our other equation. So we're going to get that our I2 is equal to a 30 amps minus 11I1 if we move this over. But then we can multiply everything by this negative one to get rid of the negative on the left side. So we're actually going to have an 11I1 minus 30 amps. Then we can divide everything by 2, so this will be all over 2. I'm going to then plug this into here. So this is what we're going to get here. I'm going to multiply everything by 2 to get rid of that 2 on the denominator, and then multiply 19 into both of these, factoring it in. So after we multiply everything by 2 and factor our 19 in, we're going to get this. From here, I'm going to add these two together. We're going to get 205I1, and then we're going to add these together after I move the 570 amps to the right side. Now we can add these, and this will give us 410 amps on the right. If we divide this, we're going to get that our I1 is equal to 2 amps. So that's how we get that, and we can write in here that our I1 is 2. So now we should be able to solve it because we know the current going through it, right? Well, that's actually incorrect, because if we look at the left part, we know that current's flowing into this 2I, but we also know that current's flowing in this way into our 2 ohm resistor. So that means it's going to have a negative current flowing through it, or we're going to have to subtract something from it. So this I right here is really going to be our I1 minus our I2. So we have to solve for our I2. Well, we do have a formula for it, and we can really just plug in what we know right here, our I1. We'll plug it back in. I'm just going to use this equation right here, and we'll plug in our I1 to be negative 4 amps. That's the I1 right there. And this is plus 19I2, and set equal to negative 80 amps. Plugging this into a calculator, we're going to get that our I2 is equal to negative 4 amps. And this is our I2. Now that we know our I2 and I1, we can plug them in here. So we know that our I1 is 2, and we know that our I2 is a negative 4. So we're going to have a minus negative 4 in here, and this is all going to be squared times the resistance, which we know as 2 ohms. So these two together, that's going to be 6 squared will give us 36, times 2 is equal to 72. So that means the power delivered from our system is 72 watts. And that is how you would go about solving this problem.